All right, welcome back, Algebra 2. So, example 2 says, consider the polynomial function defined below. So, let me go ahead and give you p of x here. So, p of x is defined by 6x to the fifth power. So, 6x to the fifth power minus 3x to the fourth power plus 4x squared minus 2x minus 70. Okay, so there's your polynomial. It is a fifth degree because of this degree. This exponent here is the highest one you see. And it also, 1, 2, 3, 4, 5 is a 5-term polynomial with the leading coefficient of 6. So they just want to know simply what is p of 2. So since p of 2 here, x got replaced with 2, you literally just say, okay, p of 2. That means I just put a 2 everywhere I see an x here. So 6 times 2 to the fifth power. Of course, following order of operations, as always, minus 3 times 2 to the fourth power plus 4 times 2 squared minus 2x minus 70. So we just have to essentially evaluate this for 2. So essentially we're going to go ahead and take the powers of 2 first, just because following order of exponents. Alrighty, so we're going to ignore the 6 just for a second here. So we have 6 times 2 to the fifth power is 32. So we're going to do 6 times 32 here in a second. Minus 3. 2 to the fourth power gives me 16. I should know your powers pretty well after the last unit. Plus, we'll keep the 4 on the outside. And then 2 squared is another 4. So that's 4 times 4 here. Minus, oops, I forgot to put a 2 in here. Hopefully you caught that. This should actually be a 2 instead of x. I got a little carried away there. Forgot to plug in that 2 there. So 2 times 2 we can just do, which is 4, and then minus 70. Okay, a lot of minuses, which we'll have to be careful about over here. So then we just have 6 times 32, which gives us 192. So 192. Sorry, I'm trying to write as neat as possible. Minus 3 times 16. 3 times 16 is 48, so minus 48. Plus, this is a 9, by the way, in case you can't read it. 192 minus 48 plus, well, 4 times 4 is 16. Minus 4 minus 70. Okay, so we just got to evaluate all that here. So equals 192 minus 48 plus 16, so 144 that is right here, plus 16 is 160, minus the 4 would be 156, minus a 70 would be 86 for our final answer here. So 86 is P of 2. So 86, and then this whole way, this just was P of 2. We don't need to do anything with that 2. A lot of people try to divide by 2. You don't need to do that. It's just function notation. So this literally says, whoops, P of 2 is 86. So now we need to graph this function in the window, negative 5 to the positive 5 and negative 120 to the positive 120, which I'm actually going to have to show you guys how to do tomorrow. So please remind me to do that. My calculator is not functioning properly at this point in time. So we're going to circle this. If I forget, you guys remind me. You should know how to graph the function. We're just putting in this for our y equals. But I do want to show you what that looks like, so I will actually graph that with you guys tomorrow and show you how to, or remind you rather, how to change the window here. Something we've done before, but not much. So I'll remind you how to change your window and show you what picture we should be getting here. So put that on pause unless you can do it on your own and draw what you see. Okay, example 3. Says, starting with the summer after her senior year in high school, Yolanda Fish worked to save money for medical school. At the end of each summer, she put her money in a savings account with an annual yield of 6%. Yolanda is planning to go to medical school in the fall following her 4th year in college. How much money will be in her account when she goes to medical school if no other money is added or withdrawn? So essentially, you got the years that she worked here during college. She says after senior year, this is how much she saved. After her 1st year in college, this is how much she saved, 2,200. Her 2nd year in college, she saved 2,100, and her 3rd year in college was $3,000. So let's go ahead, just like we normally do with word problems. Let's go ahead and get the important parts. Obviously, this table is pretty important since they decided to make a whole table of it. So this guy, we're going to go ahead and copy onto the next slide so we have room to work. This 6%, pretty important because that's our rate here. And then also it's following her 4th year in college. So how many years have we had to save? 1, 2, 3, 4. And then that next year is when she will actually be using that money. So this will be actually kind of interesting that you're going to see here. So just keep that in mind what we're going to do with it. All right, so I've copied over that table. A few other key pieces of information we need to remember is that our rate was 6%. And that she has her 4th year, so she's got 4 years that she's saving money. So the 4th year, oops, sorry, I guess that shouldn't have an S. It is 4 years though, so equals 4 years. So that's how long we have to save for our money. So essentially, if we start with that $1,500, now I am going to change this rate. And remember, we always had to do 100% plus that 6%. So essentially, she's earning 106% because they're not taking any money away from her. They're adding to her original amount. So if I were to change that to a rate, remember we do 2 decimal places, so it's actually 1.06 is actually going to be our R. So I'm actually going to call that, in this case, X, just because we like to see X's in polynomials. And I'm going to keep that as X because that way she can shop around and maybe see if she can get a better interest rate and maybe put 8% in there just to see what that actually does to her money. So essentially we're going to take our initial amount for senior year and we say, okay, $1,500 times our rate, but remember we called our rate X here because we don't want to lock ourselves in. And then how long has that particular $1,500 been actually sitting in the bank? Well, for senior year, that's been 1 year, 2 years, 3 years, and then after that 4th year is when she's actually going to take that money out. So it's actually been in there for 4 years. So I want to make my exponent 4. Okay, so that's the money from her senior year. And then we say, okay, but then we also then worked after our 1st year in college. So that was $2,200, okay, flat rate. But then she put it in the bank. Right now it's 6%, but remember we want to use X to be generic. And how long has that money been sitting in there? Well, she's got 1, 2, and then 3 years to get to her 4th year, because remember that's just the 3rd here. So this guy's exponent is 3, because it's been sitting in there for 3 years. And then finally we add to it the 2,100 that's been sitting in there for only now 2 years. So that would have an exponent of 2, plus that 3,000 she earned after her 3rd year in college, which has been sitting in there for 1 year, which you could say X to the first, but we really don't need that first power there. So this guy will actually help us solve for how much money she actually had. Now remember, we put in X here just so that we would not have to write this out, but we're actually going to have to use this 1.06 power, or excuse me, rate. So what that actually looks like is you're going to have 1,500 times 1.06 to the 4th power. So that's our first term here, plus 2,200 times 1.06 to this was the 3rd power, plus 2,100 to the 1.06 power, or excuse me, 1.06 to the 2nd power, and then plus 3,000 to the 1.06. I'm sorry, this handwriting is awful. I'm using a different laptop than I'm normally used to, so I hope you can read that. Essentially, I just took the X's and plugged in our actual rate, which is 1.06, into that. So then we take our calculator, so please put this on pause if you haven't gotten your calculator yet, And we're actually just going to plug this whole thing in, start to finish. You can do it all as one into our calculator and see what it gives us out as our final total. So hopefully you didn't have any trouble entering this in. If you enter it in just as it is right here, you should be just fine in figuring out how much total money she has. When you do that, you should get the grand total of, that's my dollar sign, don't make fun of it, $10,000, $10,053 and 51 cents, if we're going to be exact. So she ends up with $10,053.51. So not too shabby of earnings and not too shabby of a spot to be in order to go to college. All right, so we're going to go ahead and you guys, to give it a shot, I want to see these problems done. You have three parts to do, essentially. We're going to expand the polynomial after I give it to you. I would like its degree, its leading coefficient, and then find f of -2 when you do this here. So let me get my pen back. I'm going to actually give you f of x here. So f of x is going to be, let's see here. Let's go ahead and do 2x plus 5, and I would like you to take that and I would like you to square it. So essentially you're going to expand this part out. F of x is just going to be f of x. Expand this part out. F of x is going to equal whatever you get here, of course in standard form is what it would like. Find the degree, put your degree right here. Whatever your leading coefficient is, put that right here. And then find f of -2. So just plug -2 in for all x's that you see here, and you should get a number answer. So please make sure you do all of those before you come into class tomorrow. Those will be what I'm looking for when you come in, just to double check to make sure that you know what you're doing, which hopefully you do. All right, and that's all I have for you tonight, Algebra 2, so have a great night, and I'll see you in the morning.